So we're going to try to learn a little bit about the midsegment and the midsegment theorem tonight, and then tomorrow we'll kind of work quickly through this, wrap this up as it's not too complicated, and then we can go over the quizzes and also start reviewing for the angles test, which will probably be on Friday, so you can count on that. So the midsegment, as you can see here, just call it a segment connecting two midpoints of opposite sides. The midsegment theorem, I pointed this out in class, is the segment joining midpoints of two sides of a triangle that is parallel to the third side and also half the length. Either highlight, underline, or circle those key words because that's the most important part of the midsegment theorem. Two most important parts, parallel and half the length. Keep that in mind. So on this particular picture, it tells us in the wording that D is the midpoint of AB. So D is the midpoint of AB there. It also tells us that E is the midpoint of BC. So E is the midpoint on that side. It's also marked in the picture because if you have these markings and they're equal, that means that point must be in the middle. So it's in words and it's in markings. But D and E are now definitely midpoints, and the segment connecting those two midpoints, so segment DE that connects those midpoints, that's the midsegment. Now the midsegment theorem says two different things. Number one, it says that DE is parallel to AC. So as soon as you know it's a midsegment, those two are always going to be parallel. You can think of it as the middle and the bottom, but really the two sides that look parallel are parallel if you definitely have a midsegment. The other thing to know is that DE is exactly half the length of AC. So two of these make one of AC. It doesn't look it. It looks a little bigger when it's up here because it's an optical illusion, but when you bring it down and put it next to the other one, you can see that it really is half the length of the bottom. So the middle is always half the bottom is double the middle, however you want to look at it. Both are helpful, but those two things are true, parallel and half the length. So in number one at the bottom here, it's definitely a midsegment. It doesn't say midpoint anywhere, but because we have those markings, we know that's in the middle, and the same thing on the other side, we know that's in the middle. So this is a midsegment, which means it's not only parallel to this, but it's half the length. So X must be 12 centimeters. Number two on the next page. Again, the markings tell us that it's a midsegment. We need to know that they're midpoints, and the markings show that. So 13.5 is marked here, but that's the smaller one. So that's half of this. There's really, think about it like this, there's really two 13.5s in there, which means that X is 27 centimeters, double the 13.5. In question B, we have a midsegment again because of the markings. And here's the common mistake people make. They just get into algebra and they think, oh, 3x is equal to 42. But it's not equal. You can't say equal if it's clearly not. This is not the same as this. It's exactly half of it. So what you should do is double the small one, because 2 of these equals 42. So what we really have is 6x equals 42. Divide by 6, and the variable for x is 7. So don't just immediately set it equal to each other. That's not the same as that. But 2 of these is the same as that, and you have to make sure to double the smaller one before you do the math. Okay, question C. This gets into parallel lines and a transversal a little bit. One of the facts was that the middle is also going to be parallel to the other side. So if these are parallel with a midsegment, then we have corresponding angles. So X is also 68 degrees. So because of parallelism, the angles will be the same. There's not enough information on number 3 unless I told you that that was a midpoint and that was a midpoint, whatever letters you want to call them. Once I tell you that those are midpoints, then you can say this is a midsegment that's both parallel and half the distance. But I would first have to tell you either verbally or in writing somewhere that those dots were midpoints. Same thing in number 4. You don't know that these 2 points are midpoints, but once I tell you that, or if I had markings like that, then you would know that these red dots are midpoints, meaning that 3x doesn't equal x plus 40, but 2 of them does, because this needs 2 of them. So it's 6x equals x plus 40. Subtract the x to the other side, and x would be 8. And again, same thing here. I would first have to tell you that these points are in the middle by either showing you this and this, or flat out telling you that those were midpoints. Don't make this mistake. Do not stop here and say 2x is 3x plus 8. You can tell that it's not. It's too short. But 2 of them do. So it's 4x equals 3x plus 8. And once you subtract the 3x to the other side, you have 1x equals 8. Remember to pause this and go back anytime you need some clarification. I don't want you just to scribble down what I'm writing. I want you to understand it. Okay? In number 6, we have to add a couple of points in for this to make sense. It says DE is parallel to AB. That must mean that that's DE. So add that to your picture, or you can't do the problem without that. Once DE is there, it's telling us that this is parallel to this. So we have the midsegment there. It also means that if DE is 10, how big is AB? 20. It's twice as big. Another set of parallel sides would be EF. This is going to be point F. EF is parallel to AC. If those two are parallel and EF is 7, that means that AC is 14, all the way over here. And the third piece of information is that DF is parallel to BC. DF and BC. And if DF is 8, that means that CB must be twice that big, because the smaller parallel one is always half of the bigger parallel one. So the question says, find the perimeter, which is all the way around the outside of ABC. So if you wanted to go all the way around it, you now have 14, 16, and 20, which is 50 units.